Hello everyone, my name is Praful John. In this tutorial, we'll be discussing about Autogluon. So what is Autogluon? It enables easy to use and easy to extend AutoML with a focus on deep learning and real world applications like spanning image, text, or tabular data. In this video, we'll be discussing about tabular data. So for standard data sets that are represented as tables is the tabular data, and Autogluon can produce models to predict the values in one column based on the values in the other columns of the table. So we can, like this, with a single call to the fit function, you can achieve high accuracy in standard supervised learning tasks such as regression and classifications. And we also don't need to deal with, data cleaning and feature engineering and like stuff like hyperparameter optimization and also model selection. So I have some collabs that we'll be discussing by line, and we'll be discussing what's happening in those collabs. Let me share my screen. So this is a quick start to the tabular Autogluon tabular. So what we'll be doing in this video is we'll see how to use tabular predictor to predict the value of target column based on the tabular data set, the different columns of the tabular data. So we'll begin with installing Autogluon. So here are some commands that will install Autogluon for us and the tabular data set for us. So what is tabular data? It is basically a subclass of pandas data framework and frame sorry so what is tabular dataset? It is a subclass of pandas data frame, and by using this data URL we are going to extract the information and store it in the trained data, and we're showing the head of the data, which shows the 5 columns of the data. What we are trying to do is we are trying to predict signature in this, and there are about 18 signature unique values, and let's describe the label signature of the data. So it will give the count, the mean, and the standard deviation and stuff like that. And now what we do is we just train the data. So what we're doing is we are taking a predictor variable, and we are using tabular predictor and giving it a label and just calling the function fit with the trained data. And what it's going to do is it's going to look in the models and find the best model for you. See, so our prediction is done. Once we have a predictor that is fit on the training data set, we can load a separate set of data to test it basically. So that is what we're going to do here. We're going to take the test data and from the same URL, and now we're going to predict uh, use the same function, the model we have designed, this predictor model. And after we are done with that, it will start predicting the value. And now what we're going to do is we are going to evaluate the model. So it is giving me 95% of accuracy, which is pretty amazing. And what all models it used while using the fit function, it is going to show it here. So it used 13 models, out of which weighted assemble L2 back the first position with a 95% of accuracy. So this is the conclusion, and this is a quick start tutorial for Autogluon's basic, and we predict functionality using tabular dataset and tabular predictor. So let's move on to the next collab. So in this collab, this is an Autogluon tabular in depth, and so basically, it says that if you are new to this, we should go and look at the quick start one, so that we get a more broader idea of what's going on in this. So this tutorial describes how you can exert greater control when using AutoGluon's fit or the predict function. So there will be functions, variables like presets, which will be helping us in the hyperparameter tuning. We can have different values of the presets. Let's go and check it out. What all things we can do. We can have the best quality preset. We can have a high quality one, and we can have a medium quality one. So what it is doing is basically it depends on how much time you give to the model. If you are obviously using a best quality one, it will take more time. It will search in and fit in many models. Uh, let's say 15 to 20 models, and That is how it will take more time and give you the best model that can fit on your data. So again, we start by downloading all the dependencies for Autogluon Tabular, and then we import tabular dataset and tabular predictor, which we'll be using to tabular dataset to import the files from the link, basically the tabular dataset from the link, and tabular predictor will help in making the model. So here, what we are going to do is we're going to predict occupation, and we are going to see how many occupation are there. So there are about 15 unique occupation, out of which you have to predict one. So predicting an occupation is the task of this collab, and so usually we don't use we try the sole purpose of using Autogluon is we stay away from the hassle of basically the hyperparameter tuning. So we can just simply specify that you want a best quality model, and it will you provide it with the resources, maybe the GPUs and CPUs and TPUs to it. And what it's going to do is you can set a timer for it that take so much time, like maybe 2 3 days, or maybe like 2 3 hours, and come up with the best model possible. And what you need to do is run the command, give it all these resources that it needs, and it will come out with the best model possible. So what you can do is, if you don't have a strong reason to provide your own validation dataset, uh, we can like omit the tuning data argument, and there are many arguments like predict and fit. You can use that directly. And in this one, we are trying to do the hyperparameter tuning, and here we are with the predict function. What we are doing is we are testing it as the model is ready. The predictor model is ready, and will print the predictor will print the predictor model, and will also evaluate the model, and it will also try to find the summary. So here also again the weighted assemble L2 is back the first position by 38% of score accuracy. So again, the point here is like you need to give it more resources, and maybe some GPUs and TPUs so that it can work properly. So the score with like 38% is not that good. I was running this collab on CPU. That is why I think it did not get ample amount to train the data, basically train the model. So again, we are trying to use different number of different parameters like time limit. We have set it to 30 seconds. So it will try to generate a predictor model in 30 seconds. And we can also save the path of a model, and we can use it for later. And so I already explained what presets are. So that is how uh, this collab works. Let's go to the next one. So in this collab, we have a multimodal data tables, which has tabular text and images in the data set. What we're going to do is we're going to use the pet finder dataset. We'll be using pet finder dataset. The pet finder dataset provides information about shelter animals that appear on their adoption profile, with the goal to predict the adoption rate of that animal. So first we'll start with installing Autogluon, and then now what we're going to do is we're going to get that zip file, and we're going to unzip that file here, and basically after that we're going to load the data. So here file is the original zip file downloaded, and it is processed. So this file is processed, and we have different CSV available with us. And now what we're going to do is we're going to here we can see like test train dev CSVs, as well as we also have two directories as test images and train images, which contain basically the JPG files. And we'll be using dev data as testing data, and dev contains the ground truth label for like the predictor.reader mode. And after that, we're going to again load the data. Right now, we're using the read CSV from pandas for that. It's just showing the data, how it looks like. So it has 25 columns and 3 rows. And using all these columns, we're trying to predict if what are the chances of if it getting adopted. So will the label is adoption speed. Here we'll prepare the image column, and so right now Autogluon supports only one image per row. So since the pet finder dataset contains one or more images per row, we need to pre-process the image column to only contain the first image of each row. So that is what we're doing here. We are using a anonymous function to do that, and like taking out the first image and putting it on the on that column. And now AutoGluon loads images based on the file path provided by image column. So here we update the path to point to the correct location on our disk. That is what we're doing here. And after that, our data is ready. So we have one image in this one cell. So now this data is ready for the basically prediction, and we'll try to display the data, and we'll also so now here we are with the fitting with the data using the tabular predictor. Now we will train a tabular predictor on the data set which we have. We basically did some tuning of data set. We cleaned it and made it compatible for AutoGluon, and we'll be using feature metadata and hyperparameters we defined prior. And what we're going to do is uh, we're going to set the preset quality to high quality, and it will definitely take some time. But it will give us the best possible model for that. Again, now it's time for evaluation. So we call the evaluate function on the test data. The accuracy it shows is 30% since it is a multimodal data. So the accuracy is less. And here, cat boost bag L1 full bags the first position. So let's move on to the multi-label collab. In the multi-label prediction, we wish to predict multiple columns of a table based on the values in the remaining columns of the table. And here we present a simple strategy to do this with Autogluon, which simply maintains a separate tabular predictor object for each column which is being predicted. So we have a multi-label predictor class with us, which is multi-label predictor, uh, which will be managing different tabular predictor objects for us. We'll start with the installation, and so we have multi-label predictor file with us. We're gonna we have the training data with us, and now for training the data what we're going to do is we're going to get the tabular data set, and we'll tell the subsample size and random state of it. So we've given the mm, different labels, that is education, num, education, and class. So these columns are our target to predict what are each. So regression is associated with education num, so we'll be predicting basically a number for that. And education is a multi-class problem, and class is a binary problem. So we're predicting if it's there or not for this. And we have a safe path for it, which specifies folder to store the train model. So we'll save the model here in the safe path. And this is the time we are giving to the predictor model. We can increase the time definitely so that it gives an output of a better model which has a better accuracy. Now what we're going to do is we're going to call multi-predictor, multi-level predictor, and we're going to fit the train data. And once it is done, it's going to give us the data. It's going to give us the model. After we are done training the model, we can easily use multi-level predictor to predict all the labels in new data. And now what we're going to do is we'll be accessing the tabular predictor for one label. We can also directly work with tabular predictor for any of the labels as follows. However, we usually do consider label correlation as false before training if we later plan to use an individual tabular predictor to predict just one label rather than all the labels predicted by the multi-label predictor. So what we're gonna do is we have already predicted we have already made the model using the multi-label predictor, and if we want the model now the model to predict using one label, so that is what we're doing here. Now we'll be training models with GPU support, and this what we're going to do is we are going to train a multi-model data, and which has tabular text and image data in it. So uh, we try to present how to train an ensemble which can utilize tabular text and image data in this. But what we're going to do is instead of using CPUs, we'll be using GPUs for this and see how we can increase our accuracy from the data. So the default installation does not support GPU training. However, like GPU can be enabled via special installation. If NUM's GPUs is set, we can use the GPU for this, and we're gonna engineer a new feature out of a tabular data, like out of whatever feature that is present, so that this new feature can basically help us to predict the target column. We have an example. We already have an AutoML pipeline feature generator, which we'll be using here, and we'll be installing tabular Autogluon tabular for that. So what we're doing is we took a data set, and now we're trying to um, feature a new engineering out of feature. Now we are trying to implement feature engineering out of it. So it's it is the same thing which we are doing. We are using this AutoML pipeline feature generator to fit the model for DFX, basically. So right now we are here with the data, and we have the label as label in this. And what we're trying to do is we are trying to predict, uh, we're trying to make a new predictor model, and we're trying to fit using the hyperparameter as GBM, the light GBM which we want to predict, and we are gonna generate a new feature. So that is why we pass this AutoML pipeline feature generator, and now the new feature has been generated, and it has a category type out of the all we discussed earlier, as it can be any type like numerical, categorical, date time, or text column, out of which we have generated a categorical type feature. And previously, the data related to the B column was in zeros and ones. Now we are converted into more better categorical form, and we are also trying to handle the missing values. And now, if we like try to reprocess this whole again in customization of feature engineering to customize your feature generation pipeline, it is recommended to call pipeline feature generator passing in non-default parameter to other feature generators as required. For example, if we think downstream models will benefit from removing their categorical values and replacing with NAN, we can supply the parameter maximum num cat to category feature generator like as below. So if we then dump out the transform data, we can see that all columns have been converted to numerical, because that's what most models require. We don't want a categorical column, we want a numerical column so that algorithms can work properly. So see, we have converted all the columns to numerical columns, and for the ones that are not available, we convert them to NaN. So here, that is what we have done. Okay. Thank you so much for watching this video. I hope you learned something out of this. And please do start using AutoGluon. It is an amazing library. Uh,